Hello everyone, am I audible?
Yes, sir.
Okay. Yeah, so let's start with this. Guys, so sorry we couldn't have this extra class which we have discussed. No, I was not sick. Yeah, so we understood first derivative test in the last class, as well as how to apply that first derivative test on different questions, right? So first derivative test is basically an approach of uh, increasing and decreasing function to determine the local minimas and local maximas of a function, right? Now let's solve one more question. Let's start with this fourth question, which is sin x plus cos x, right? So fx is given as sin x plus cos x, and we need to identify. Uh, okay, with this, we will always be given an interval. Okay, so we will be solving it in some time. But before solving this, I would like to tell some more concepts and also tell you why do we need them. So we do know about first derivative test now. So first of all, there are two methods which we have discussed. I mean, I have told you that we have not discussed the method, but yes, I have told you that there are two methods by which you can identify whether I mean, how to identify local minimas and local maximas of a function, right? The first method was this first derivative test, right? And now after this, we will discuss our second method, which is second derivative test, right? So before going further, let's first move on to second derivative test. And a very important question to answer: why do we need it? If we have first derivative test and that is going smooth, then why do we need second derivative test? Yes, we do need second derivative test. Why? I'll show you. See, let's say we want to find out what are the local minimas and local maximas of this function, sin x plus cos x. Okay. So what is the approach? First, we will find out f dash x, right? F dash x will be cos x minus sin x. And after this, we will apply wavy curve method. Wavy curve says that you have to identify cos x minus sin x. I mean, your function, when your function is greater than equal to 0, or when your function is negative. If you want to identify for an expression, when this expression is positive and when this expression is negative, then wavy curve is your method, right? Now, the problem is when we apply wavy curve in cos x minus sin x, it's not easy to apply wavy curve in any form other than algebraic functions. Algebraic functions, wavy curve is very good. Wavy curve works well, really well, in fact, in case of all the algebraic functions. But other than algebraic functions, when we talk about trigonometric functions, when we talk about exponential function, logarithmic functions, then wavy curve is not that useful, right? We can still apply it, but the questions become difficult, first of all. That is why to find out about all the functions, not just algebraic functions, because our focus is not just on algebraic functions, but rather on every function that is involved. And there are three common types of functions that we observe very frequently, and they are algebraic functions, which for which we can always apply first derivative test or wavy curve method, right? First derivative test. But for the functions like trigonometric functions, exponential functions, logarithmic functions, it is better to apply second derivative test to identify their point of local minimas and local maximas, because you won't be able to plot them on a number line that easily, right? So that is our problem, that if we face any expression, if we are finding out the local minimas and maximas of functions different than other than algebraic functions, then how do we approach them? Because wavy curve becomes very, very difficult in these questions, right? So the approach to all of these questions is second derivative test. Now, what does second derivative test says? Second derivative test says that if you have a function, consider you have this function y is equals to fx, right? And I want to identify its local minimum or local maximum or point of inflection. Although I just need local minima and maxima, but I do know that there is another thing, point of inflection, right? And we have already discussed about critical points, right? So we are interested in critical points. Critical points mean there are a bunch of points. There's the critical points is basically a collection of points. All those points where your f dash x is 0, either your f dash x is 0, right? Okay, I think I have discussed this already, right? Yeah, where your f dash x is 0, that means either extreme point or point of inflection, or your f dash x does not exist. Like in this case, I told you f dash x does not exist at x is equals to 1, but still this is a critical point. 2 and 3, at 2 and 3, f dash x is 0. So this fits the first definition, but x is equals to 1 fits the second definition. X is equals to 1 is a critical point because of the second reason. And second reason says that wherever your f dash x is not existing, all those points are critical points, right? And these critical points are important. But critical point, consider critical point as a superset, right? It is a superset of all those points which we need. What do we need? We need extreme points, right? But critical set is a superset of extreme points, right? Because critical points contain a lot more points, right? But all of these points are important. Always remember this. All of these points are important. 3 types of points, all of them are important. But right now, our focus is only on extreme points or point of inflection, right? So how to find out extreme points or point of inflection in case of second derivative test? So let's say we have a function y is equals to fx. So how do we approach this? To approach this, just a minute. Yeah. So let's say we have this function consider y is equals to fx. Now, what do we do? Our first step would be, okay, so I'm writing here step 1. Step 1, find f dash x. First of all, find f dash x and find the roots of okay, let me write it directly in one step, one go only. So first point is find the roots of f dash x is equals to 0. Now, what does this mean? You will have a function y is equals to fx. First, you will differentiate that function and you will put that function, the derivative part of that function equals to 0, right? And you will find the roots of this function. So let's say if I have a function sin x plus cos x, right? Then first I will find out f dash x, which is cos x minus sin x. And then I will find out the roots of this equation. Roots of this equation mean I will equate this equation equals to 0. I will solve this. I will solve this. And I will tell you all the answers which are possible. So if I take x here from 0 to 2 pi, that is one rotation, one full rotation. So if I take x from 0 to 2 pi, then cos x and sin x are equal at 2 values, at pi by 4 and 5 pi by 4. First quadrant, third quadrant. First quadrant, both are positive. Third quadrant, both are negative. So they are equal at these 2 points, right? So what do we need to do? Step 1 is take your function, right? Differentiate that function. Put the derivative part equals to 0 and find out the roots, right? Now we will receive some roots. Let's say these roots are like this. Let's say the roots obtained in step 1 are, let's say these are the roots. We don't know how many roots we will get for every, I mean, for each equation, we will get some different number of roots. So it is not always possible to have same number of roots. So that is why what I'm doing is I'm writing it and generalizing this as x1, x2 up to xn. So let's say we have an equation y is equals to fx. We want to identify its point of local maximas and local minimas. First, I will differentiate that function. First, I will differentiate. Harif, we are discussing about second derivative test right now. And I'll give you an overview of what have we discussed. So let's say we have a function y is equals to fx, right? And we want to identify what are the points of local minimas or maximas or point of inflection for this function. Then these are the steps. These are the steps that we have to follow. First, we will find out the differentiation derivative of that function, which is given. So let's say the function is sin x plus cos x. So first I will find out f dash x. F dash x is cos x minus sin x, the differentiation of this part, right? Differentiation of this part. Then I will put this part, whatever the derivative part is, that which is cos x minus sin x in this case, I will equate this with 0. Basically, I will make an equation f dash x is equals to 0, and I will find out the roots of this equation. Okay. Now, the second step is, let's say the roots are x is equals to x1, x is equals to x2, x is equals to x3, and similarly x is equals to xn. So it means there are n roots, right? In the first step, we got n roots, right? Then we will take these roots, and we will put them in the second derivative of this function, in the second derivative of this part. So what does that mean? First, in the first step, we have differentiated this function once. Now we will differentiate this again. So find f double dash x. You find f double dash x, right? You find f double dash x, and in this expression f double dash x, you put these points, whatever were the roots, x1, x2, x3 up to xn. Whatever were the roots of the equation f dash x is equals to 0, you take all of these roots, right? And then you find out f double dash x, that is the second derivative of the same function, right? And then you keep these points. Okay, so find f double dash x, right? Now for x1, or to check the status of x1, let's write it like this. To check the status of x1, right? Put x1 in this double derivative part, f double dash x, right? If you put x1 here, it becomes f double dash x1. So in place of x, you put x1, right? If after putting this value, your whole value is greater than 0, that is positive, then this signifies x is equals to x1 is a point of local minimum. If after putting x1 in this double derivative part, your value is negative, it means that x is equals to x1 is a point of local maximum. And if your double derivative is also 0 at this point, then it means that x is equals to x1 is a point of inflection. Very simple rule. So I would again like to answer your first question, that why are we understanding second derivative test? Because it is easy. It is easy in a lot of cases. It is difficult when finding derivative of a function is difficult. But it is very easy if you can easily find out the differentiation, if you can easily apply the formula of differentiation. So if your function is not very complex, very big, In all such cases, your second derivative test can really reduce your calculations and can quickly solve the question. So this is a more robust method than first derivative test, and that is why we are following this, because it can very easily give us the status of a point, whether it is a point of local minima, local maxima, or point of inflection, whatever it is. Chalo, now let's try to apply this in one question, in the above question only, in this question. Yeah. So let me take this question. Anji, everybody done? And in the similar way, by the way, you can check for all the points. This is just for x is equals to x1. If you want to check what is the status of x2, whether x2 is a point of local minima, point of local maxima, or point of inflection, then you can apply the same steps. You can put x is equals to x2 in the f double dash x, and then identify whether the value is positive or negative or zero. And similarly, can make your decision. Okay, now let's try to apply this. That will certainly boost our confidence as well as understanding of the concept. So the question given is, in this case, the question given is sin x plus cos x, right? And we have to identify its maximum and minimum value in x belongs to 0 to 2, right? This I'm giving you, although this we will talk about one more topic, which is maximum and minimum values in a closed interval. Right now, we are observing a function over its domain, that is from minus infinity to plus infinity, or whatever its domain is. We are not specifying. This is the first time. This is the first time when we have specified x. Right now, x is from 0 to 2 pi, right? But we have never specified x before this question. So we will have to, I mean, I'll make you understand this concept. I'll explain this concept. But before that, let's just generally solve this question. So we want to identify minimum and maximum values of this function, given function. And we are going to apply second derivative test to do so. So let's go to step one. Step one says that first of all, find out f dash x. So I'm finding out f dash x, which is cos x minus sin x. Now, find the roots of. Now, find the roots of this equation. F dash x is equals to 0. You know what is your f dash x. You will use this equation of f dash x and equate it to 0. From there, you can find out your roots. So you want to identify all the x where cos x and sin x are equal. There are 2x in between 0 to 2 pi. In between 0 to 2 pi, there are 2x which can satisfy this. And they are pi by 4, 45 degree, and 225 degree, which is 5 pi by 4. There are 2x from 0 to 2 pi. There are 2x from 0 to 2 pi. Right? In which gives us f dash x is equals to 0. Right? Now, f dash x is 0. F dash x is equals to 0. We will identify whether these points are point of local minimas or point of local maximas. For that, now we will find out f double dash x. F double dash x mane just differentiate your f dash x. Just differentiate your f dash x once more. Differentiate again, right? For the same function f dash x, which you have found out after differentiating fx, just differentiate this one more time. So cos x would be minus sin x, and then this would be minus, and sin x would be cos x. So your f double dash x is minus sin x minus cos x. Now I want to know whether x is equals to pi by 4 is a point of local minima or local maxima or point of inflection. Very easy. So I will write for x is equals to pi by 4, right? I want to find out f double dash pi by 4. So you put your pi by 4 point here. That is, in place of x, you replace x with pi by 4. Now, what's this value? Minus sine 45 degree, money minus 1 by root 2. And this is again same. So this becomes minus 2 by root 2, which is minus root 2. Negative. If you see negative, this is less than 0. The value comes out to be negative. What does that mean? That means x is equals to pi by 4 is a point of local maxima. So always remember, they work in an opposite way. If your second derivative test value is negative, then it is a point of local maxima. Negative maxima, positive minima. Always works like that. Now, if I want to check for x is equals to pi by 4, I will simply put this point and find out the value. Even if I'm not able to find out the exact value, that is also okay. I just want to find out whether this is positive or negative. And now you can very easily identify whether it's positive or negative. How? See, this angle is 225 degree, right? So mane third quadrant. Sine in third quadrant is negative. There is already a negative here. So this value is negative. This value inside the bracket value. Sine of pi by 4 is a negative value, right? And then it gets multiplied with another negative. So this whole becomes positive. This whole becomes positive. And similarly for this, cos pi by 4 is negative. Then again, this gets multiplied with another negative. This becomes positive. So overall value will be positive. Now, what that value will be? That I can tell you. Sine pi by 4 will be minus 1 by root 2 minus cos pi by 4 is again minus 1 by root 2. Right? And you can see that this is also 1 by root 2. This is also plus 1 by root 2. So it becomes 2 by root 2, which is root 2, which is greater than 0. Which is greater than 0. Right? Hence, we can say that x is equals to 5 pi by 4 is point of local minimum. That is how we can very easily identify whether a point in context of a question is its point of local minima, point of local maxima, or point of inflection. Just follow these simple 2-3 steps. First step is find f dash x. Find out the roots of f dash x is equals to 0. Then find f double dash x. Put all of these roots in the equation, f double dash x. If the value comes out positive, point of local minima. If the value comes out negative, point of local minima, point of local maxima. And if value comes out to be 0, then point of inflection. And as soon as we understand this approach, second derivative test, we are good to go with any question now. There is no question which is not possible after this. So please note this down and feel free to ask me your doubts. Because we have already covered this topic. So I think this is just a basic concept in addition to what we have learned. And along with this, I would also like to tell you one more thing, which is the last topic of this, and which is obviously, related to what we have learned. Chavez, yes, if there is a point of inflection, then the value would come out 0. For second derivative test, the value would be 0. Then we can find out point of inflection. If f double dash x1 at some point x1 is 0, then we say that x is equals to x1 is a point of inflection. It may be asked or it may not be asked. That is a different question. But how to find out that we should know. So what we have learned by far is that how can we find out the local minima and local maxima of a function? And we do know what does local minimum and local maximum means. Local minimum माने local का गुंडा, local goon, basically the value which is highest in its neighborhood, and local minimum माने the value which is the point at which the value of the function is lowest in its neighborhood, right? But let's say we want to find out. So let's consider this situation. Consider a function y is equals to fx, right? Y is equals to fx, and we want to find out its maximum and minimum value in x belongs to a to b. Now, first of all, understand the difference. I'll very clearly explain. I'll try to very clearly explain this concept, what we are talking about. And this can be done with the graph. Yeah. Let's say we have a graph like this. Okay. Let's say this is the graph of y is equals to f. This can be anything. I'm just taking an example just to make you guys understand what do we mean here. Okay. Now we know that the lowest value of this function is here, right? And highest value, I mean, this is a point of local maxima, but this is not the highest value of the function, right? This is somewhere, these points are depicting the highest value of y, right? This is our basic understanding of the function. Okay. So we do know that this is the lowest value of the function, but let's say we are asked that find out the minimum and maximum value of the function between this interval, the portion that I have cut, between this interval only. Let's say this is A and this is B. So we have to only find out the value of the minimum value of the function and maximum value of the function in this given interval. Now in this interval, the minimum value is at this point only, and the maximum value is at this point only. Let's say if I change the interval, let's say if I say that, okay, find out the maximum and minimum value from this to this, A1 to B. Now this is the minimum value. Now this is the minimum value, right? So it matters if I change the interval, if I change the values of x, and if I say that, okay, no, don't tell me over the whole values of x. मेरे को पूरी सारी वैल्यूज ऑफ एक्स के लिए मत बता कुछ भी जो बता रहे हैं. मैं बोल रहा हूं मेरे को सिर्फ एक्स की वैल्यू 2 से लेके 5 तक के लिए बता. क्या मिनिमम वैल्यू है इस फंक्शन की? जब एक्स 2 से 5 के बीच में होगा तो एफ एक्स की क्या मिनिमम वैल्यू होगी और एफ एक्स की क्या मैक्सिमम वैल्यू होगी. आई जस्ट वांट टू अंडरस्टैंड दिस. आई डू नॉट वांट the values of fx over the whole interval of x, or for x minus infinity to plus infinity. I just want the values of x for x belongs to 2 to 5, and then tell me when x is from 2 to 5 what is the maximum and what is the minimum value of fx. That is our question. Now you can see that this is a very different question. This is a very different question that from whatever we have been doing yet, right? So this is a different question, but the solution is same. Question is different, but the solution is same. How? अरे वही करने यार जो भी सीख के आए हैं, बस समझ लो इसके भी steps. Now I want to find out when the value would be minimum and maximum in this given interval. So what I would do is, again, I will go with the same steps. So first step would be find roots of f dash x is equals to 0. Find all the roots of f dash x is equals to 0, right? Let's say the roots are x1, x2 up to xn. These are the roots of f dash x is equals to 0. Then you will only take only those roots which lie between a to b. So if I am asking you the values of fx from x2 to 5, and let's say the root of x is 6, then why would I take 6? I to only want the values for 2 to 5. I don't give a damn to x is equals to 6, right? I really don't care about x is equals to any values which is greater than 5 or any value which is lesser than 2, they are not important to me, because I only want the observations of fx for x is equals to 2 to 5, right? So what I can do is I can already ignore all those values which do not lie between a to b. So take all those values, take all the values which belongs to a to b. Take all the values which belongs to a to b from our above roots. Take all the values which belong to a to b from above roots. Now let's say these values are, let's say these values are x1 and x2, capital X1 and capital X2. Let's say these values from the out of these small x1, small x2 up to small xn, there are two values which satisfy this criteria. That is, there are two values which lie between a to b. And let's say these values are x is equals to x1 and x is equals to x2. Then what would be our third step? Now, what you would do is you will take this point a, small b, and these two values, x1 and x2. You will take 4 points. पहले मैं एक बार हिंदी में बता देता हूँ, ये बात तुमको बहुत ही आसानी से। सिंपल काम यही करना है कि एफ डैश एक्स इज इक्वल्स टू 0 रखेंगे, रूट्स निकालेंगे, जितने भी रूट्स आएंगे उसमें से वो सारे रूट्स उठा लेंगे जो ए से बी के बीच में, यानी कि जिस इंटरवल के बीच में हमसे पूछा गया है, सिर्फ उस इंटरवल के बीच में जो रूट्स सारे होंगे हम उनको उठा लेंगे, राइट? जितने भी रूट्स आएंगे सबको उठाएंगे इस गिवन इंटरवल के बीच में, और साथ साथ ये जो एंड पॉइंट्स है ना इंटरवल के, स्मॉल ए एंड स्मॉल बी, ये भी उठाएंगे. सो कंसिडर now Austin, now we will consider all these roots which satisfy second step, and along with them we will also consider these end points of the interval, that is x is equals to a and x is equals to b. So now we will consider all these points a, capital X1, capital X2 and b. There are 4 points to consider now. Okay, so what is the different thing? That we will always take the points of this closed interval along with the roots. Now we will also take these 2 points, small a and small b, and we will find out the values of fx at all of these points. Find out fa, small fa, fx1, fx2 and fb to find out or to decide for maxima, which will be global maxima in this interval. So you take all the roots which lie between the interval and also the endpoints of the interval. Then you find out the value of the function at all these points, and you take the maximum value as whatever is the maximum out of all these. That will be the maximum value of fx in that interval, and whatever will be the minimum among all of these will be the minimum value in this interval. And that is what we have exactly did in the last question. Exactly that is what we have done. In the last interval, we were given, in the last question, we were given an interval from 0 to 2 pi. Right? Now, if I want to find out the points, or let's say if the question was find out the maximum and minimum values, so the question was this. Let's say the question was identify maximum and minimum values of fx in the interval 0 to 2 pi, right? So first, what I would do is I would again find out all these points. There are 2 points, pi by 4 and 5 pi by 4. I will tell them that, okay, this is the point of local maxima. This is the point of local minima. Now what I would do is I would take all these points. So what I would do is take x is equals to 0, pi by 4, 5 pi by 4, and 2 pi. So 0 and 2 pi, 0 and 2 pi from here. 0 and 2 pi from here, because these were the endpoints of the interval which was given. And pi by 4 and 5 pi by 4 are my roots. I will find out all these values. So first, find out f0. Now I know fx is sine x plus cos x. This is fx. So f0 would be 1. Sine 0 plus cos 0. F0 would be 1. Similarly, f pi by 4 would be root 2. F5 pi by 4. You can find out them. I mean, I am telling you directly. And f2 pi would be minus 1. You can see that this is the maximum value, and you can see that this is the minimum value among the all four. That is why we can say that this is minima in x belongs to 0 to 2 pi, and this we can say maxima in x belongs to 0 to 2 pi. So when x is from 0 to 2 pi, your maximum value can be root 2, and this will exist at x is equals to pi by 4 for this given function. And your minimum value from 0 to 2 pi can be 5 minus root 2, and that will exist at x is equals to 5 pi by 4. Please note this down and ask me any query. Feel free to ask me any query, because right now we are done with all the concepts. We have been solving these type of questions for the last 2 classes. So I believe that if you don't have any doubt, and if you're not facing any problem in this, then you will be able to answer me the next questions. Okay, in that case, let's start with some questions. Uh, Try to find out what we can do here. And if you have any problem, please feel free to ask me. Take as many hints as you want, but just try to solve these questions. Okay. I mean, don't leave them. Try to solve them. I'm here. I'll help you out. But मेरे साथ करोगे अगर अभी बैठ के थोड़ा गलत करो, खूब गलत करो, कोई चलेगा यार. जितनी गलतियां करनी है करो, बट मेरे साथ करो. अगर तुम करोगे नहीं तो आएगा नहीं, ये डेफिनेटली. और इससे एक 6 मार्क्स का क्वेश्चन है, डेफिनेटली. There is a 6 mark question which is fixed from this portion. Let me tell you this. Okay, chalo, let's solve 20th. Find the intervals in which the function f given by this and x is also given from 0 to 2 pi is strictly increasing or strictly decreasing. Oh, no. This is the question. My bad. We have to solve maximum and minimum. No? Oh, so the problems given are word problems. So obviously word problems will be the most important one here, but before that, I would like you to solve some questions if I can find. Okay, so we're not able to find out the questions from this portion. So Let's, yeah, I'll give you questions. So, guys, am I audible? Oh, I was mute. I was on mute. I didn't know that. Yeah, Austin, I have muted on purpose this time, but I forgot the last time. So there's a series of questions that will be followed now. Try to answer all of these, and I'll try to include variety of questions in this. So we have to basically find out local minima and maxima for all these points. Also identify so find the local minima and maxima if any of the following function. Right. And also find out these values. Find also the local minima and local maxima values. So basically you have to tell us the value of x as well as value of y for these questions. So first question is fx is equals to x into root 1 minus x, and x is given to you from 0 to 1. X is in between 0 to 1, but this is not a closed interval, right? This is not a closed interval. Okay, so we can start these questions. I will write some more questions. Yeah, please try to solve these questions in, let's start with the first one and ask me whenever you have any doubt. Guys, feel free to text me about the points, about the roots of f dash x is equals to 0. If that step is not correct, then I don't think we should move further. Uh, the question will be incorrect. So please try to tell me whenever you get f dash x is equals to 0 at any point. That will only validate your question. हाँ भाई, सवाल हुआ नहीं हुआ, क्या कर रहे हो? अबे कोई तो आंसर बताओ, एक ये तो बताओ कि पॉइंट्स क्या आ रहे हैं, कुछ तो बताओ भाई। ऐसे कैसे चलेगा? खत्म कर दें फिर क्लास? टाटा बाय बाय। आंसर्स देने पड़ेंगे भाई। नहीं दोगे तो बाय। ना कब तक? अब तो नीचे आ जा शंकर। वो मूवी देखी है तुमने, नो वन किल जेसिका? एंड दीज गाइज वर आर्ग्यूइंग, मैं वहां पे नहीं था, मैं नीचे था, मैं नीचे था। एंड जस्ट केप्ट आस्किंग हिम, शंकर बता दे सच। मैं नीचे था। अरे अब तो नीचे आ जा शंकर, कब तक ऊपर रहेगा? अच्छा, at x is equals to 2 by 3, it is maxima for first one. Also find out the value. That is f2 by 3. What is f2 by 3? Okay. So let's check the first one. Shaviz has answered for the first one that at x is equals to 2 by 3, it will be maximum. ठीक है भाई, कर लेते हैं यार चेक f डबल डैश x। सबसे पहले f डैश x निकाल दो यार, क्या होगा? रूट ओवर 1 माइनस एक्स प्लस x इंटू 1 बाई रूट ओवर 1 माइनस एक्स इंटू -1. -1 will be due to this. We'll have to apply product rule, right? And this can be further changed to this. So this is your f dash x. This is your f dash x. If you want to find out critical points, then there will be 2 critical points from this. And if you want to find out the roots of f dash x is equals to 0, then that should be x is equals to 1 by 2. So Chavez, your answer is incorrect, definitely. That is why I have asked you to tell me whenever you get. Yeah, not minus half, Austin. It should be plus half. See, when we differentiate this root now, so this will be 1 upon 2. Sorry, my bad. 1 by 2 root over this, and then this would be -1. So this should be twice. Oh, correct. Now the answer may change. 2 minus 3x. 2 by 3. Correct here. Sorry, my bad. This should be 2 minus 3x over root over 1 minus x. So if you want to find out critical points, so first of all, critical points. So critical points are when f dash x is 0, right? That should be at 2 by 3. And when your f dash x is not defined, that should be at 1. But if I want to find out roots of f dash x is equals to 0, it means that I just want to find out when this expression would be 0. And this expression would be 0, meaning numerator will be 0. So which means that 2 is equals to 3x, meaning x is equals to 2 by 3. Right? X is equals to 2 by 3. Now, to find out whether it's a point of local minima or maxima, either we can go through first derivative or second derivative. But in this particular case, I guess first derivative will be easy because we can directly eliminate this root over 1 minus x. This quantity would always be positive. So this only depends on 2 minus 3x, right? And you can observe that this root will always give you a positive quantity. So take a value which is less than 2 by 3 and take a value which is greater than 2 by 3, and you can directly have your answer. But if not, then you can also go through f double dash x. And in that case, your differentiation would be root over this, then root over 1 minus x, then the differentiation of this, which would be -3 minus, then your 2 minus 3x would be as it is, and this would be 1 over 2 root over 1 minus x, then this would be minus plus. There would be a minus here, so this becomes plus. And this can be further solved in the form of this, that this -6, 1 minus x plus 2 minus 3x divided by 2 over 1 minus x to the power 3 by 2. So you can see that f double dash x is also not कि बहुत ही स्ट्रेट फॉरवर्ड है और बहुत ही इजीली निकल जाएगा. Sometimes it may be difficult. It depends really on the expression. So first derivative test would be much, much less calculative than the second derivative test in this case. So okay, cool. So we can further solve this f double dash x. Now, as there is no closed interval, so there is only one value to consider, which is x is equals to 2 by 3. So this becomes minus 6 plus 6x. Okay, minus 6 plus 2, minus 4 minus 9x divided by twice over 1 minus x to the power 3 by 2. For now, I want to check whether x is equals to 2 by 3 is a point of minima, maxima, or what. So for x is equals to 2 by 3, I will put this point here. If I put this 2 by 3 here, minus 4 minus 9 into 2 by 3 divided by 2 into 1 minus 2 by 3 to the whole power 3 by 2, right? So this becomes minus 10 divided by twice of 1 by 3 to the power 3 by 2. Now we know this denominator is positive. So this overall value is less than 0, which means that this point of local maximum. And the value would be, the maximum value would be f2 by 3, which is 2 by 3 root over 1 minus 2 by 3, x into 1 minus x, which means that f2 by 3 would be 2 by 3 root 3. Can be further solved to 2 root 3 by 9. This should be your answer. This is the maximum value, and it occurs at x is equals to 2 by 3. Right? This should be a correct answer for first part. Chavez has answered this question correctly, by the way. Please go on to second question. Find out if there is a point of local maxima or minima. If yes, then find out that point and also find out the values at those points. Austin, if the interval is closed, then only we will take these endpoints. If the interval is not closed, then we won't take these points. Guys, 3 questions are for homework, so let's solve them by the time you come to the next class. Okay, let's finish the class early today. So you can leave the class and we will move on to the word problems in the next class. That is on Wednesday. Right. So please solve all of these questions, come with your doubts, and if you have doubts in questions or concepts, then please feel free to ask. Okay.